Well, earlier we have introduced the term called access control while defining the classes and the members of classes. And in fact, in the definition of a class, if you recall that we had the one term called access control followed by class and a class name. And the same thing is being used for defining the variables. And we have mentioned that the term access control is essentially used to implement encapsulation of the variables and the methods that are for a class. And the different access control strategies or the schemes that are available in Java, or in fact in most of the programming object-oriented systems, are that there are three types really. The fourth is a package, which is something, a collection. These are called the private, protected, and public. We have so far mainly concerned ourselves with the term called the public, and which actually among these the three terms, when we use these attributes with a class or a members of a class, what it really means that if a member is declared as a private, it will be accessible only inside the class. Therefore, when we define a method when a variable, say, is defined private in a class, then that variable will be accessible only to the methods defined in the class. Such members, however, cannot be inherited, as we will see later, that is, the subclass of a class cannot inherit private members. The attribute, the protected, is used that if you define a member to be protected, then they can be accessed in the same class. That means it and also can be inherited by subclasses, provided those codes which are in the same package. That means all methods in the subclass and then this definition should be included in the same package as the class in which the member which has been declared protected belongs to. The term public, we have seen that public classes we have used earlier also. The public members can be accessed anywhere in the class, and it can be inherited by all subclasses. That means this term, when you declare something as public, it is essentially you are not defining any protection. So for example, if you remember, when we define the terms as point, we define the variables int x, int y, and then when we say that the public class circle, then the circle has a point center, and this center, when center is a point, now the variables int x and int y it will be possible to access them directly in other class, in the class circle. Whereas if we declare them as a private, only the methods that will be defined for the class point can operate on them. So any other class cannot directly access such variables or such members. And so that is what's the difference. So the public, when you define something as public, that will be accessible from anywhere. So there is absolutely no protection or no encapsulation in that sense, excepting that it is defined in a class, is available for public members. On the other hand, when we say that it is private, it is probably the strongest. That means it is not visible. Something is not visible outside the class. So if a variable, we say that, like say if the points x and y coordinates are declared private, they will not be visible outside the class point. And such members can be accessed only by the methods which are defined in that class. The difference of protected somewhat falls between the strongest record, the encapsulation which is defined by the attribute private, and the weakest, that is a public. And the protected members can be accessed by, or also can be accessed and inherited by subclasses, and provided, of course, the code is defined in the package. The concept of package, which will come back again later on in our courses, so we will define it more in detail. Essentially, it can be thought of sort of a containers of class and interfaces, and it helps the names of classes compartmentalize. Meaning simply that we can think it of a package may contain several classes, definitions of the classes, and together with these methods and also the interface definitions. And then later on, when we try to, if you have two such packages, then one can refer the method of one package by defining the package name followed by the class name and the method name. So in a sense, it is somewhat compartmentalizes the classes. In Java, there are several packages that are available for doing, for instance, I/O operations, sometimes graphic operations, and so on. So for that, the appropriate packages and the class definitions are included and used. So if you look at it, what we are talking about, the access levels in Java, you see that the highest or the strongest requirement is the private, which means if you tabular form, it looks like that whether it will be actually any member which is defined as a private, whether it will be defined, it can be used inside the class itself, it is yes, but not to subclasses, not to any other package, and in no other classes even in the same package. If you declare protected, it is yes, it can same class member within the class they can be used. Within a subclass also, since they are inherited, they can be used. In the package, of course, the requirement is that they must be defined in the same package, and others no other subclass, of course, no other class other than the class or its subclasses can access those variable or members. When it's public, it is open, and therefore it is no encapsulation here. So now with these definitions or these three levels of access control, primarily private, protected, and public, let us now go into the inheritance, which is a very important property, as we have seen earlier in any object-oriented style of design, that how inheritance is handled, and how we can, and what are the properties of the type of inheritance that is supported in Java. If we recall in our earlier discussion, when object-oriented classes were introduced, if you remember, we were talking about subclass or the specialized classes of a given class. For example, we had defined employee engineer as a special type of employee, and permanent employee is also an employee, and similarly computer engineer is a engineer. In this manner, we constructed a hierarchy of classes, and we had defined inheritance. There are two types of inheritance we have introduced. When we treat in a subclass as an extends the properties of the superclass, and another case subclass introduces additional restrictions. In Java, we will we'll use this philosophy, and as we'll see that the definition in Java the subclass will be assumed to extend the properties of the superclass. Second characteristics of inheritance we had defined is that there are two types of inheritance. One we call the single inheritance, when each subclass has only one immediate superclass, and the other one is a multiple inheritance, where a subclass can inherit properties from more than one superclass. In Java, we will follow, we are available the single inheritance, that is a superclass, a class can have at most one superclass. However, we will see later that when we discuss our interface, and in the interface, after defining interface, we can see that it will be possible to somewhere implement in multiple inheritance with the help of interface in Java. So when we talk about inheritance, let's be more specific, that we will assume that a subclass can have at most one parent, and therefore Java in the language only supports single inheritance. So therefore, what we have now with this basic definitions, so let's come back to Java inheritance. So as I mentioned, a subclass is assumed to extend a class, Now in Java, there is one class which is at the root of every class hierarchy, and that is called object class. So there are certain properties of object class which will be inherited by its subclasses. As I have already mentioned about the access control, in which we have mentioned that the protected members can be inherited but not the private. So that's what we are re-emphasizing. A subclass inherits superclass members which are declared public or protected. That means any member which has been declared private will not be available to the subclass for inheritance. The next is, if there is since access control is somewhat you may or may not define for every member, the default case, that is subclasses inherit superclass without any access specifier, provided the subclass is in the same package as the superclass. So if we define the subclass inside the same package as the superclass, then all default members, that means the members which have been, for which no explicit access control has been mentioned, will be inherited by the subclasses. A subclass can rename a superclass member. This is where we come the concept of polymorphism, in a sense that therefore now when we subclass renames a superclass member, it is this where new name will be confined within the subclass and or its subordinate classes or subclasses, provided it is not declared private. A subclass can override superclass methods except the methods declared final. So these are the properties of inheritance in Java, which we should remember. The major thing is that a subclass can have at most one sense the properties of the class. We have an object class at the root of the hierarchy. The subclass will inherit all members of the superclass which are not declared private when it is defined in the same package. If it is not defined in the same package, then it cannot inherit protected members as well as the default members. It is possible to rename the members or the methods defined in the superclass. So let's go back to an example to illustrate this. For instance, we have already earlier defined what is a point. If you remember, we said that a point is a class point which has two members, int and x and y. So these are the x coordinates of class point. Now I can define a subclass of it. So that's what we said, that a public class 3D point, say it is a two-dimensional point, then it must have another coordinate. So extends point. So it is a subclass of point class, and in which there are two coordinates x and y, and we define the constructor for this. Like say in the case of a point, we define these constructors, and then similarly we can define a constructor for 3D points, and we get int u, v and w. So we define with the parameterized point constructor with the three values x, y and z coordinates given. Note that I am, without explicitly defining x here inside the class, these x and y coordinates are inherited because the public class point had the two members x and y declared public. Had we declared them as a private, then they cannot be, we could not inherit them in the 3D point. Similarly, if they were declared protected in this case, then the 3D point, unless it is defined in the class is defined in the same package, they could not be inherited. And then we have the constructor, so x equal to u, v, w, and therefore we have a initialization or of a 3D point. Now we have mentioned earlier just now, that the subclass can rename superclass members and subclass can override superclass methods except the methods declared final. We have discussed about final method. So let us try to illustrate and how does this help in overriding. So this is in essence what we earlier discussed about different types of overriding in object-oriented design, and how does it work in the case of in Java. So let's take an example, very simple. We have a method overriding for this. Illustrate this. Suppose we have a class called public class diagram. Is a class we define. It may have some other variable, other members. One is we define the string, is of type string, is a string class, and it is this is a diagram. It's one of the member, and one diagram has a side which is of type integer. In the class, say public int area, which computes the area, and say that system this method area prints the diagram does not have an area, and it returns 0. And this is the constructor for the diagram class, and this diagram it says that it is set side equal to x, so it's a parameterized, so the side value gets x. Now let us try to see another example, or which is a subclass of it. The subclass of it is that public class square extends diagram. Note that what we are saying is that we have a public class is a square is a subclass of diagram. Now when we have a subclass of a diagram, then it will inherit from the diagram some of the properties of diagrams, that is a member. So therefore it will inherit name, it will inherit side. However, what happens, say that this is a square int length. Let us say this is the constructor for this diagram for the class square, and what we are saying square int length, this constructor is we are calling super length. That means it will be the same constructor which is parent class as, which in this example is a diagram. So therefore when with the length parameter which is called, this constructor will be used, and we will have a square as an instance of a square can be created with a new square int length, which in that case which will use this constructor. We'll first use this, and then from which we are calling the constructor for its parent class, which is the diagram, and as a result we'll have the one instance of a square. And now what is where the problem we was talking about the method that is overriding. Note that earlier we have defined public int area, in which this is the method which has been used. System out print line diagram does not have an area, returns 0. Now suppose since square has an area, we can do one thing. We can say that look here, we have a new area. Now we are redefining, this is where we are redefining the area inside the class square, which is a subclass of diagram, and in which says that the square area is the product of or the square of its length or the side, and return the square area. So therefore when this one is used for computation of an area, if the present instance is an instance of a square, then this method will be used instead, that this area will be used for computation instead of this one. So this is where we have the problem, what we call the method overriding, and how Java supports method overriding in implementation of the in using or calling the appropriate methods which should be used for a particular instance. So therefore recalling what we have just now said, or the properties of the inheritance, we have said that inheritance, it is possible to rename superclass members. If we want, we could have renamed the length to something else, side or any other one. We could have we can override the superclass methods. The method area was available to the to this to square, which was defined in the diagram. This is definitely was inherited by the class square, but we deliberately did a new method for evaluating the area of a square. As a consequence, whenever we are trying to compute the area of a square, it is no point in saying that it doesn't have an area or returns 0. Rather, we should use the method area here as we have defined. So this is exactly the same way which we have talked about the different inheritance, and how does the inheritance can be used to redefine different methods, and when they are used, some of the methods are used, how the what sort of polymorphism is supported or supported in the language here. So this is an example of types of overriding that is possible. And again we repeat that had we defined the method here public instead of public, if we define the method to be private, this method also could not be inherited by the class, the parent class methods or the other members. But if they are protected or public, they can be, and it can be redefined, and so that so as to have more correct definitions or more appropriate method for that type of subclasses. The next concept that we had discussed in connection with the general properties of the objects or the classes is the concept of abstract class. If you recall, we have said that while defining the classes, that an abstract class is a class which does not have a direct instance. Mind it, it can be all the definition, that it will include the definition of the class, it will include its members, access control, everything. But one cannot create an instance of such a class. However, a subclass of an abstract class may have an instance. That means if I define a subclass of an abstract class, then it is possible to create instances of the subclass. So basically abstract classes are used to define methods to be inherited by all its subclasses. This helps in keeping the code elsewhere and then only redefining those or overriding those methods which are specific to a particular subclass. Let's take an example. Suppose we define abstract class A. This is the keyword will be abstract. This should be abstract class A. And in which you see that we are defining one method called abstract void print class, and then another method void another method. This is not there, and then where the code for the another method is that this is a second method. So we have two methods, one we call an abstract, another is the another method, and in which the code for this is given. Now let us say I define a class B which extends A. Now mind it, it is not possible to create an instance of class A. So that when you use a new new operator, if you remember when you are creating an instance where you are using new with a constructor, it's not possible to create an instance of class A. That is, if I define something like that, class A, and say small a is an instance of class A, and if you try to write class A new now this is wrong, because it is not possible to create an instance of class A. So class A is something which is an abstract, it does not have any other instance. So the class A, so this is class A, and so when we say that A is of type A, abstract class, and we define A bracket, so this is This is the abstract class is the keyword. So in this case A is an abstract class, and we have defined A of type A, new A, then no instance of A. This is wrong, because no instance of A can be created. This one has to remember, because the class A has been declared as an abstract class. On the other hand, if I say that class B extends A, in this case the class B is a subclass of A, as by definitions of we have defined subclasses. Now it is clearly possible to define an instance of B is an instance of B, small b, and we define new B this. It is possible to create an instance of B, because, or if you have another constructor for it is possible. So this is permissible. However, on the other, as I mentioned earlier, it is not possible to define. This is wrong. This is not permitted. So this is the difference between a abstract class and a concrete class, which we have so far been dealing with. A concrete class, you can create an instance of a concrete class, whereas for an abstract class no such instance can be created, but its subclasses can have. For example, in this case, let us define class C, which is a public static. In the class C, let us say we define a method, and in which we define, say, data of type B, then we can create an instance of type B, and then we can use the data print class. Note that in the earlier definitions of the class, we are now defined a new method, which is not an abstract method. We defined a method that is a concrete method, void print class, which is that implementation of print class in B. Now when we invoke this statement, or this operation, or this method in here, then we can say that data.print class will print implementation of this state. This string will be printed here. And then when we say that data dot another method, note that what is happening, data being an instance of class B and B extends A, so by definition B also inherits this method, another method, and therefore what will be printed here according to this in these two statements. First, it will print implementation of print class. This statement will be printed, and then this is due to this one, and this method, which is inherited by B from A, when this is executed, what you will get? You will get this is a second method. So this term will be printed. This is a second method. So what therefore we have seen, that although an abstract class cannot have its any instance, it is defined in this. Here we have defined a method which probably can be used in its subclasses, and that like here the class B will have the another method available to it, because it has been, in this case we have not specified any access specifier. So assuming that class B is defined in the same package, it will be available to class B, and the class B then when we call the methods in class, for instance in class B, it essentially both the methods, both print class as well as the class another method will be available to it. And also we can see that we have here defined the method print class again, which was defined earlier an abstract method. Here we have defined a concrete method for print class. So therefore the difference, to repeat, An abstract class that does not will have no instance. It is merely, you can think it of some sort of a template which is used to define all the methods which will be useful, or club them together into one place, and so that it can be inherited in subclasses, and then all these instances can use them in its whenever they are required. So what we have seen so far, that inheritance in this type of situation helps us to define, to construct concrete classes from abstract classes, and then allow some instances to be created. Otherwise, all the restrictions or the rules of inheritance that we have mentioned are still applicable, and alright. So the next thing that we need to look at in this lecture, or in fact we had been using from the beginning this term package. So let's take an example, very simple example of a package. And as we have mentioned earlier, that a package is essentially can be thought of as a container for classes and interfaces, and it helps the names of classes compartmentalized. That's what we have mentioned. So a package will contain lots of class definitions as well as the interface definitions. We'll come back to interface later on. So let's take an example how the package is defined in Java. So the keyword is that it's creating a package is a package my diagram. So this is a package I am defining, and in the package my diagram we can define different classes. For example, I have defined public class circle is one example class. We can have public class point, public class triangle, and then so we can go on defining many classes as well as the interfaces inside the package. So all of them will be kept inside the package, and then when you want to use a package, we have to use the keyword import my diagram start dot start. That's the one you have. This is the so the my diagram is the name of the package, and now when I try to create a new circle, so circle definition is already there, class circle has been defined. So what I can do now, circle C is a new my diagram circle C. So therefore there is a constructor of circle as we have seen in the class, and then my diagram is a package name and circle is this one. Now one thing one has to see, why does it help in keeping the names confined in a package? For example, if I define another package, say package, let's define another package, your diagram. Now if I define your diagram as a new package, and in which we can define again another class, public class circle. Now this definition of a circle may be different from this way, although one can define another, say we can also define something, say let us say public or protected class square. Again, and then when we say that we can now call, we can use a circle C1 equal to new your diagram dot circle. Now if I do that, look here, then not this circle definition will be used, this class constructor will be used, but rather the circle which you have defined here will be used to create the circle C1. Similarly, we can use another construction, that is, say let's define square S equal to new your diagram dot square. So create an instance square. So here we are creating an instance of square which is defined as per this class is defined in the package new diagram. So basically what is happening that any ambiguity between the whenever you have two names common in this case, it will be resolved by looking at the package to which the definition we are looking at by identifying the class which by first of all looking into the package and then into the class. One can similarly go into the other subclasses of for example, we can define in the class package new diagram, my diagram can also, besides this, can all the other classes we have mentioned can also contain new subclasses, say that protected class say equilateral triangles, triangle extends triangle. Now if I define this, now this class is a subclass of the triangle and then it will inherit properties from here or from the triangle, and again with the property now since triangle has three sides, so we can say that in equilateral triangle all the sides are same, so that's the we can introduce this restriction. So the package now contains the definition of the class triangle as well as the definitions of equilateral triangle. So this is how what we had said that now one can also should observe that when we use the word protected, now if we define this class, triangle, equilateral triangle in a different package, then it will not be able to inherit this the class triangle at all. The properties of the class triangle that the members of class triangle cannot be inherited since we have and if the members of the class triangles are, say for example here we have side, one property say let's say protected side is a line, say side 1. Now the side 1 being a protected member, it cannot be inherited by equilateral triangle. This is the problem. So the keyword protected means a subclass can inherit its properties of this triangle class, provided in this case the protected is the keyword. The protected keyword is this side is a member of class triangle and it has been declared protected. So equilateral triangle can inherit the side provided this equilateral triangle is defined in the same package. If we had defined it in a different package, for example not in my diagram but in your diagram, then in this package, then it will not be able to inherit the side 1 as its member because it was declared protected in the class triangle and which was defined in a different package. So this is the restriction. This is how the access control is also, that package concept of package also helps in introducing access control to the members of a variable by declaring them protected. So today in this lecture we have seen therefore what are the different types of access control that is supported in Java. We have seen the concept of inheritance supported in what are the types of inheritance and what are the properties of inheritance supported in Java. That is, it is a single inheritance. It only a member can have at most one superclass. That a subclass can have at most one superclass, and subclass will inherit members of its superclass unless they are they are declared as private. So private members it will not be able to inherit, but all public and protected members it will be able to inherit. Again, protected members can be inherited provided the subclass is defined in the same package, and then it is possible to rename the superclass members. It is possible to override the superclass methods. And lastly, we have also seen that what do you mean by abstract classes, and what are the properties of abstract classes in Java. That is, an abstract class cannot have an instance, but its subclasses can have. So with this, now we conclude today, and the next lecture will look at the concept of interface specifications in Java.